Okay, Unit 7, Polynomials Review. Adding and subtracting polynomials. This is combining, distribution and combining like terms. So when it's addition, there is no distribution required. All you gotta do is combine like terms. So let's go with red here. Looking at our m's, we have a 3m and a negative 2m, so that is 1m. Our n's, negative 1, negative 3 is negative 4n. Plus 4 minus 5 is minus 1. So no distribution there, just combining like terms. Same thing on number 2. X squared can only pair up with x squared. That gives us 9x squared. X's only pair with other x's, so we have, is that a plus? Yes, plus 7x plus 1 minus 1 cancels out, so we have just that. Subtraction is the same, except we do have distribution here. We have a negative 1 that has to get distributed. So it gives us negative 5x squared plus x plus 1. Then we combine like terms. 4x squared and negative 5x squared is negative x squared. 8x and x is 9x plus 1 plus 2. Number 4, this is a tricky one. We're subtracting 3x squared plus x plus 7 from x squared plus 4x plus 9. So it is not 3x squared minus x squared. It is the opposite. We're taking this and subtracting from that. So we need to rewrite this like x squared plus 4x plus 9 minus 3x squared plus x plus 7. So that's the problem that they're giving us. Then we distribute the negative. Minus 3x squared, minus x, minus 7, then combine like terms. So negative 2x squared, 4x minus x is plus 3x, 9 minus 7 is plus 2. Be careful, don't subtract that backwards. Number 5, here we have some distribution and combining like terms. We have 2y times y is 2y squared. 2y times negative 7 is minus 14y. Negative 3y times y, negative 3y squared. Negative 3y times 5 is negative 15y. Then we can combine like terms. 2y squared, negative 3y squared is negative y squared. 14y, or negative 14y, negative 15y is negative 29y. So there's the first topic you need to know, adding and subtracting polynomials. We have multiplying polynomials. This is FOIL, or double distribution. 2x times x, 2x squared. 2x times 7 is plus 14x. Negative 5 times x is negative 5x. Those will have to be combined, those like terms there. Minus 35. Combine these, we end up with 2x squared plus 9x minus 35. Number 7, this is a tricky one. Do not just square the 4x and square the 1. 16x squared plus 1 is not right. That's the most common wrong answer. Don't do that. This is still a double distribution problem. It's 4x squared, 4x plus 1 times itself. So when I double distribute, I get 16x squared plus 4x plus another 4x plus 1. So 16x squared plus 8x plus 1. Number 8, we have almost like a, no, not triple distribution because we're only distributing twice, but we have an extra term over here. It just means we have an extra thing we're distributing to. So we still have to distribute both of these. X times x squared is x to the third, x times 4x is plus 4x squared, and x times 2 is plus 2x. That's our first distribution. Then we have the 3. 3 times x squared is plus 3x squared. I'm lining it up with its like term here. 3 times 4x is plus 12x. 3 times 2 is 6. So when I combine my like terms, go green here, I have x to the third power plus 7x squared plus 14x plus 6. There is our product. Number 9, find the area. Area of rectangle is length times width. So we're taking the length, multiplying it by the width. That's just a distribution problem. So parentheses around there and a 6x on the outside. 6x times x squared is 6x to the third minus 12x squared plus 48x. So just a multiplication problem set up a little bit differently than you're used to seeing. Factoring trinomials, this is the X box. We're trying to break this up into the binomials that look like that. So this is the hard type, 3x squared. I do not have a GCF, so the top, 3 times 2 is 6. The bottom, negative 5. Whoops. That's going to give us negative 3 times negative 2. X minus 3, x minus 2. We have our a, which is 3, we have to divide by. So, simplify our fractions. X minus 1. This one will not simplify, so move 3 over. 3x minus 2. There, those are our factors. 11, x squared plus 10x. This is a little bit different. I have a GCF here. They both have an x. So I can factor out an x, undistribute an x, and I get x plus 10, and there's nothing else I can do from there. So it's just that. Also, if you do the x box, if you don't recognize that GCF, it would be 0 on top and 10 on bottom, which would give you 0 times 10. This x is like x plus 0. It's just x. We had one of those on our pig worksheet, so that should be familiar to you. Number 12, hard type again with the 2x squared, but I recognize there's a GCF of 2, so take it out. And we end up with x squared plus 10x plus 21. So my x box. Now it's an easy type, so 21 up top, 10 on bottom, 7 and 3. We end up with x plus 7, x plus 3, and we have to have this 2 on the outside. Don't forget it. And there we go. 13, another hard type with the 3x squared. No GCF. 3, 8, and 6 have no common factors, so 6 times 3 is 18 up top, negative 8 down bottom. Trying to find two factors that multiply to be 18, add to be negative 8, and there are none. So this will not work. That means this is prime or not factorable. 14, a rectangle has an area of x squared plus 6x plus 8. What expression could represent its length and width? So this is the opposite of number 9 up top. Number 9 gave us the length and the width. Now we're looking at the area, so we just have to factor to find its two, to find the length and the width. So what multiplies? In other words, what are my two binomials that when they multiply equals that. So it's just a factoring problem that's worded a little differently. It's an easy type of factoring problem. So x box 8 and 6, that gives me 4 and 2 on the sides. X plus 4 could be my length. X plus 2 could be my width. And there's our dimensions. Number 15, we have exponential functions. This is going back to last unit. We're going to have another question or two on this test from that unit. Exponential functions are ab to the power of x. In this problem, a is our starting amount. The car started out 18,000. I'm going to use just plain 18. Each year it loses 15%. So we got 100 minus 15 is 85. Move your decimal point over. 0.85 to the power of x. I need to know what exponent will give me 10,000. When does it equal 10,000? So we have a calculator for this. We're going to go to a graph. 18 times 0.85 to the power of x. I need the graph. No, I don't need the graph. I need the table. Control T, and then just go until it's worth 10,000. And it looks like year 4, 9.3 thousand, which is when it drops below 10. So 4 years. All right, nth term. We looked at linear nth term equations a while back before Christmas. Now we have exponential. I know this is exponential because it's multiplying by 3 every time. So that tells me it's going to be a b to the power of n. So if I just do 1 times 3 to the power of n, like we've looked at before, it's going to go one term too far, so we have to back up 1 term. We do that 2 different ways. I can say 1 is my starting amount times 3 because we're tripling to the power of n minus 1. That's one way. Or I can back up to the 0th term here and divide by 3 to go backwards. So doing it that way, my first term is 1/3 times 3 to the power of n. Either one of those ways would work. 2 correct answers. So I'm going to do each one that way. 17, we're starting with 1/2, and it looks like we're multiplying by 4 each time. So times 4 to the power of n minus 1. Or if I back up and divide by 4, 1/2 divided by 4 gives me 1/8. So 1/8 times 4 to the power of n. Number 18, figure out this pattern, and this is counting up by 2's. So this is not exponential. This is linear. This is going to look more like mx plus b. So m is my starting amount, which is 14. We're going up by 2, n minus 1. Or back up to the 0th term, which would be 12, not 18. That's confusing there. 12 plus 2n. And then number 19, this is halving each time. So half, 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 keep going. 1,000 times 1/2 to the power of n minus 1. Or go backwards to the 0th term, which is doubling it. So 2,000 to the 1/2 power times 1/2 to the nth power. So 2 answers for each one. You don't need both. You just need one. Your test will be multiple choice, so you'll have to be able to point out either answer. Everybody's favorite, domain and range. I knew y'all couldn't wait to see this on another test. Domain, we're looking the left and right boundaries of this graph. So, far left is 7. Far right is 12. So my domain is everything in between. The way I say in between is this right here. Less than, x less than, from 7 to 12. That's a solid dot, and that's a solid dot, so we have equal to on both. Range, lowest to the highest. I can't see exactly what those numbers are. I wrote over them, but the lowest is 72. So all the y values are in between 72 and 91. So less than y, less than, with two solid lines. So domain is x, range is y. Domain is side to side, range is up and down. Over here we have an exponential function that goes on forever. Domain starts here at 0, it goes on forever. So all of the x values higher than 0. So every x value that is greater than or equal to 0. There's our domain. The range, highest it ever goes is there, which is 1, 2, 3, 4, 5, 6. Lowest it ever goes will be 0. That's its asymptote. So it's everything in between 0 and 6. Less than y, less than. It will equal 6. It will never equal 0. So there's our range. Last one, challenge. I'm going to let you guys figure this out on your own with no help from me. Good luck. Come prepared for your test tomorrow, and I will see y'all then. Actually, I guess I'll see you today in class. But I'll see you again tomorrow.